say good afternoon. So we're presenting Biogas. I'm Hanser, that's Sophie, that's you. And so unfortunately John, and Gabriella are not here. So yeah, and we're from Santiago. So my question to you guys is, what is global warming? Anybody?
Like the world, since we are polluting the world a lot, like the layers of the atmosphere are getting damaged, so that.
Anybody else?
Too much CO2 being produced by the humans.
True. So, according to Webster, global warming is a recent increase in the world's temperature that is believed caused by greenhouse gases such as CO2 and methane. These gases are caused by cars when they burn fossil fuels, that goes into the atmosphere, and also by smoking and decomposing waste that also creates pollution. And in the past studies by scientists, over the past 50 years, an average of the temperature of the world has increased, so we can tell that global warming is increasing. And so the issue we are addressing is poverty and global warming. Why? Because the Dominican Republic has one of the highest poverty rates in Latin America. And biogas reduces methane in the atmosphere, which reduces and takes away global warming. And so we're planning to start in Cienfuegos. Have any of you guys been to Santiago? Cienfuegos is in Santiago. Many of you probably don't really know what it is. And these people live in the trash dump of Santiago. Like in Santiago, all the trash goes to Cienfuegos, and which also creates global warming. So we can see this is Santiago, all that, and this is Cienfuegos. So all that trash that has been consumed in Santiago goes to Cienfuegos. You can tell by the size. And so that's Cienfuegos, and that's the dump. All the trash that they get, they put it in that dump. And most of the people that live there work in the dump by picking up trash. And so there's 3 levels in the dump where they have to work. And they usually get paid to 300 or 400 pesos a month.
Did you just say 300 or 400 pesos a month?
Not a month. I'm just contradicting myself. Like mostly weekly.
A week?
Yeah.
So less. Yeah. That's 8
And
hours.
I like to tell you, like the first time me going to Cienfuegos, I didn't really know. My partner you told me about it, and at first I was thinking he was lying. And until we went to the dump, it was like a mountain filled with trash. It was like a river passing down a pure black, and it was like really uncomfortable. Like you were at least 10 meters away from the dump, and like the smell, even going into Cienfuegos, the smell just came in. And so the people there rarely get paid, like I said, and they raise goats and sheep that also creates this methane gas. So now I'm going to pass it off to my partner.
Thank you. So I know you're here to know what biogas is, right? But let's give a good guess first. Okay. Does anyone have idea what biogas is? Raise your hand. It's okay. I'm here to explain to you. So yeah.
A gas produced from organic waste.
Organic waste.
That's pretty much what I was going to say.
Yeah. Thank you. So biogas is one of the natural gas, which is a flammable and which also can be used for electricity. I'm going to explain more later, but okay. So biogas, it's been quite an interesting idea for the last 20 years. It's been quite accepted idea in Europe, Asia, and Africa. And in Europe, there's an organization called the European Biogas Association. There are a total of 24 countries who are actually doing this biogas. So there are countries that we call as advanced countries, as Spain, United Kingdom, Germany, Hungary, or like Spain. So in Europe in 2012, there are over 13,800 biogas plants, which is quite a lot of number. And in Germany, there are 8,700. In Italy, there are 1,264. This was a statistic from 2012, so which means it's still increasing. So this is how countries in Europe use a biogas. I'm going to tell you later about the source of the biogas, but once they get the source and they plant the biogas plant, they move it to the first digester. And after the digester, they move to the second one, and they transform this biogas to run the electricity for each city. The good thing about this biogas plant cycle is that once you get the source, there's no other money that you have to use except for the transportation. And it continues and continues, which tells us it's sustainable. And in Africa and Asia, other than Europe, the countries in Europe and America, they come to Asia and Africa, which we think has a cool countries, and they build this biogas plant for each village. So in monthly or like weekly, they can get a free gas from this biogas plant, which is planted in the village, so which help them economically and in other many ways. So this is one actually in India, and the one is from Africa. So what are the main resources of this biogas? First is a cow manure. As you all know, cow manure produces a lot of CH4, which kills the ozone layer. And the other one is a food waste. According to the UNEP, 1/3 of the food that we produce are get lost or wasted, which is 1.3 billion tons per year. 1.3 billion tons is I can't even imagine that number. It's like a 1.3 billion elephant. Yeah, it's the same number as that. Okay, so exactly, there are two main gases that forms a biogas. First, what is CH4? As we all know, CH4 is a methane in other name, and it's a colorless and odorless, and it's non-toxic. That's very important. And it's explosive, which means it's flammable, and it's one of the causes of global warming. Next, it's also formed by CO2, also known as a carbon dioxide, which is also colorless and odorless and non-toxic, but it's not flammable. But importantly, this is necessary for the photosynthesis. I emphasize it's a non-toxic because many people actually ask me, okay, so I'm going to produce this awesome biogas, and we're planning to use it in our house. But what happens if this gas is toxic and actually damage our body? No, don't worry about it. It's non-toxic, and it's completely, you're going to be healthy even though you're using it. Okay, so this is the actual biogas cycle. So as we all know, there is a sun, and by the sun, the crops get a photosynthesis, and that crop become two different parts. Crop is a food for us and food for animals. And for the food for livestock, such as cow, they produce manure, which is organic waste. Also, crops will eat it and also become a food waste later. And this organic waste, we're going to put in the digester, which is an anaerobic treatment, and produce a biogas, which we can use for electrical and thermal energy. But cool thing about this biogas is that after we use that CH4 for the fire or for the electricity, CH4 is gone, and it only produces water, carbon dioxide, and oxygen. And this carbon dioxide, as I told you before, is a very important plant for the photosynthesis. So this cycle repeats and repeats and repeats. So we get rid of the methane that kills the ozone layer. We produce more carbon dioxide, which is good for plant to photosynthesis. So this is our first biogas digester. To tell the truth, unfortunately, this one didn't work. Because we didn't get the right proportion of the CH4 and CO2. We cannot avoid getting the CO2 from the biogas, but it's really important that we get more CH4 than CO2, so gas is actually flammable. So here we actually prepare a little activity for you to have a fun time and making a cocktail. Yeah. So can you separate in two different groups? I will separate in this way. Yeah. In two groups. Okay. So there are 5 different liquids. There are 5 different liquids that we prepared, and we actually tested all those: milk, water, lemonade, vinegar, and Coca-Cola, right? So let's think. Okay, we couldn't actually bring the cow manure. Sorry, I know you really said, yeah. So let's think that we have a cow manure and food waste inside this cup, right? So get in the group and think which liquid you're gonna put in your digester. Okay, it can be one or it can be all 5. But think reasonable, okay? Think which way gonna work the best for the digester. And you're actually going to come up here and pour the liquid inside your cup. This is group 1. Yeah. And here's the group 2.
So you're going to send one person from your group to come up here and mix your little digester fluid.
I'll give you 3 minutes.
it's to be part of the like the cellular growth and the microbes. So probably water.
I'd say
Well, probably
Yeah, but doesn't Coke like isn't that just mainly CO2 when you don't want as much CO2 as you want methane?
We don't know. Don't look at us. Don't look at us.
maybe milk. Milk is really like the industrial, like imagine. No, but it's just like
Can I see the bottle?
maybe more vinegar, water.
It's milk.
Make sure you're a science teacher.
When you send your person up, make sure they can explain why they chose those.
Cities, for example, with water to
You have 2 minutes.
and then the milk so that there's actually stuff from I think whether they have something like milk.
Yeah, make your own cocktail.
Can I keep it from a water bottle?
I'm thinking.
No, it's for me.
Can we share?
Oh yeah, of course.
Water.
Water.
Milkshake now. Yeah.
This kind of things.
Great, so make your decision.
And vinegar. That's it?
Okay.
Okay.
You stay here. Yeah. Room number 1. Okay.
You gotta be able to explain.
Now here's the drink.
Alright.
Yes.
Let's consider it.
Remember, it has to be we're in there
So we
already.
got lemonade and vinegar.
That's both, right?
Yeah.
Good choice.
Alright.
He just wants to waste our Coke.
Okay, bring them over here.
Okay, so let's see. Room number 1.
Why did you choose that?
You pick water, vinegar, and Coke. Why? First, water.
I chose lemonade, vinegar, and Coke. I chose lemonade because it's acidic. And I chose vinegar because vinegar seemed interesting. I don't know.
Yeah.
And then I chose Coke because I don't know, CO2 or something. I heard that someone say about CO2.
Okay, thank you. Room number 2.
So I chose water in order to make the environment for the germs more hospitable, since they need water for growth. Then the vinegar, because it's the most acidic component that is available, and it helps break down food probably, as in the stomach. And then milk, because milk, as in probiotics, like in yogurt, it probably has germs in order to accelerate and kickstart the production of gas.
Okay, thank you very much.
Wow.
Now, I'm going to explain whether it's going to work or not. First, lemonade, awesome choice. Yeah, vinegar, perfect. Coca-Cola, sorry, it's not going to work. As I told you, the proportion of the inside the digester is really important because it's going to produce both CH4 and CO2. And as I told you, CO2 is not flammable. So even though you produce the gas after you put a Coke, you're going to produce some gas. Yeah, but it's not going to be flammable. Group number 2. Yeah. Group number 2. Water, vinegar, and milk. Water, excellent choice. As you stated, the bacteria, they need water. And also, to not let the manure to dry, you have to pour some water. And vinegar, as I said, is a perfect choice. But milk, No. And I'm going to explain you why now. So for the biogas, there are 4 resources that we need total. Manure, food waste, water, acid. And I'm going to explain you why. Because the condition for, in order to produce that biogas, it has to take more than 2 weeks. We tried it the first week and tried the second week, didn't work. And we talked with some expert of who wrote the book called the Biogas Handbook. He said it's the anaerobic digestion, which include with the bacteria and some other germs. So for that, we have to take more than 2 weeks to actually produce CH4. So in the first 2 weeks, we're only going to produce CO2, carbon dioxide. After that, it has to be completely sealed. The gas doesn't go in and not go out. And as I said, it has to be acidic because it has to go above pH 7. So vinegar is a perfect choice to make it as acidic, but milk, no. It's going to make it as a base. And it's good to be above 35 degrees Celsius constantly, but it doesn't have to be, especially in this country. If you just clean outside, it's going to digest by itself. And the cool thing about biogas is that you cannot, other than common manure, you can use other bacteria. For example, after it rains, there's a water that stays at the same place, right? You can get a mud out of here and you can put in the digester. Because there's a different type of bacteria which can also help to digest the common manure or the food waste inside the digester.
All right. So we had some questions we had to ask ourselves before we even started to actually make any of this happen. So how can we apply our solution? So first we have to educate the people. These people who are living in Cienfuegos, they're in complete poverty, they have no money. So we have to educate them on how this would work. They have no money to buy that actual gas for cooking. So by installing these into their houses and explaining how they work, we're giving them a little bit of an education on this, and we're helping them economically. So that would be how we would apply our solution. How will this help global warming? So as you guys know, the Earth is surrounded by series of atmospheric layers, and one of them is the ozone layer. So the ozone layer is being destroyed, and that is because our pollution on Earth, and we're destroying this part of the Earth, which is very important. It prevents cancer, all kinds of, it's what's causing global warming, is this destruction of the ozone layer. So by reducing the CH4, like you said, by burning it out when we cook it, it's completely helping global warming because we're destroying what's destroying the ozone layer. So we're heroes. How will it help poverty? So like I said earlier, we're giving them the opportunity to use something that they don't have to buy. Like these tanks of gas that can be expensive to them. So they don't have to pay for gas, they can actually buy food. So that's what they actually need the gas for, to cook. So if they don't have food to cook, what's the point of having gas? How can you improve? Well, that's where you guys step in, obviously. We need you guys' opinion. But some ideas we came up with was we need to make it bigger so it can produce more gas. The one that we came up with doesn't produce enough gas for a week or so. So we need it on a much larger scale. We also need it to produce gas more efficiently, faster, so it can be enough to actually use for years to come. And how can energy be free? If you guys saw our video, that was our question at the end. Well, there's this mass production of trash. Obviously, that's a huge global issue. So that mass production of things that people don't want, by using that as an unlimited resource to create gas and energy that we can use, that's what makes it free, because nobody wants it. So that's the way we can basically help the environment. As a conclusion, our goal is to create a more efficient and a sustainable way to create gas. So it will help the people in Cienfuegos in their economic situation. We hope that this will benefit us and the community, so it will create a cleaner gas, and it will lead to a free resource. And we would like to give thanks to David House, who is the author of Biogas Manual Handbook, Dr. Seth Cohen, who is our director at SES, who allowed us to come to the GYM conference, Mr. Glenn Boyd, who is a chemistry teacher. He allowed us to use this equipment, which doesn't come easy. Ms. Jen Gonzalez is our advisor. She helped us a lot. And Max Clara, who is helpful to make our digester. So, yes, thank you for listening.
If there's any question or suggestion to improve our project here, yeah.
First of all, you guys are all very engaging presenters.
Thank you very much.
That was really great. Well done. I'm curious where you got your model to make your digester.
A model? Yeah. The first model, we got it from the internet, and we actually talked with the David House, who is the author of the Biogas Handbook. In that world of a biogas, people call it as a biogas Bible. Yeah. So I asked him the suggestion to come up with a model, and we're continuously thinking about how can we make a better one for the people to achieve that improvement. Yeah. Thank you. Other question?
Yeah, you said in one of your slides, you said that it takes, so for the first 2 weeks that you set it up, that it actually produces CO2.
Yeah.
Why did it switch to methane? Why is it
This is because of bacteria. Like, it takes the time for them to actually start to work. So bacteria is a living a creature, right? So in the first 2 weeks, they're gonna create keep developing the cell. And after that, they're actually gonna create CH4 by breaking down the manure and the food waste.
How are you guys handling the different aspects of the project? Because it seems like you are the chemistry guy, and it seems like you guys are the guys that are working on the solution. So how are you managing that? Like, do you each know like which role you have, or is it like everyone does everything?
Yeah. So we come up with the idea. For example, as you said, I'm the chemistry guy. Yeah. So I come up with some ideas to share with the other guys, and they're gonna decide whether it's gonna work or not. And actually, they come with a better idea to help the poverty in Cienfuegos, and how can we actually install it in the community. Yeah. Any other question or?
Yes.
So I think you have an awesome idea, but I'm wondering, how are you planning on getting the materials? Are you looking into sponsorships? Are you looking into fundraising to get the materials to actually build the biodigesters in these communities?
Yeah, the good thing about this biogas digester that we came up with, it's really easy to get it. So, can you actually guess the money that we spent to build the biogas digester? How much? 100? No, 100 is too cheap. Yeah.
I saw you guys had like on the little picture showed it was like some tubes, and
Yeah.
then I saw like in botellón de agua. So I'd say about like 500 pesos.
Exactly. Yeah, exactly. Yeah, we used the less than 500 peso, and which all of them is really easy to get. It's a un botellón. It's everywhere in school, and we can just get a tube. You know, there's like an ochoa that we call here, yeah, or the bejón. It's really easy to get those materials. And as I said, what goes inside is all food waste and cow manure. Especially in this country, there are cows everywhere. I'm surprised when I first came here. Yeah.
And then you said vinegar and water?
Yeah,
Vinegar and water.
Yeah, vinegar and water. That's all you need.
So the main resources we would need would be the actual pipe and the botellón. And most of those people in Cienfuegos already have that botellón because they need water. So those are obviously, we don't need to buy those. They would already have them. All we'd have to install would be the pipe and probably give them some instruction, a booklet or something that they could actually know how to use it. So all they'd have to do was refill it, and then it would work.
And to answer your question, we are planning to start by the school first. So by the school, as a class or as by the people, they're gonna donate like a 500 peso, and actually they're gonna write their name. So other than just we're installing the biogas in the community, we're trying to build kind of connection, because the Cienfuegos is considered as the poorest area in Santiago, and we are going to international school. So you can guess like an economic difference. So we're trying to build a connection between them by helping them out, by showing them love and other stuff.
Yeah. One question. When you build the replica of your digester, is that enough to provide enough gas for normal usage, perhaps cooking?
What is it?
Or
Yeah, that's like a one way that we have to improve. So we couldn't actually test how long we can use it, but first we test is the flammable. So this is the next step that we have to move on. Because according to the David House, it says for the botellón, it will be enough for the house to cook for like 2 times or 3 times. And the good thing about the digester is can you show it? Okay, no marker. Good thing about the digester is that there is a certain graph. So it goes up, produce more gas by the time, and when it hits the maximum, it goes down. So it continues to produce the methane. It's not like the one time it produces methane, all and gone. No, it continues to produce it for over time, and it goes down, and after that we have to change the materials inside the digester again.
So basically, it's going to produce gas slowly, and then once they produce enough gas to actually cook with, then once that is done, they can start refilling, and then they'll have more gas and more gas until it builds up.
Have you considered like safety implications that you might need to take in this? Because I'm going to assume that you're trying to put this into a very non-educated area.
Yeah.
And I can already foresee some biogas in the air and someone letting a mansion boom. Have you talked to any like any engineers that know like don't do this because this might be loose, or like I just think safety has to be a concern here as well.
Yeah. That's the guy that that's the why we talk with the Max. Yeah, so he's the kind of the SCS maintenance. So we come up with a valve that I can actually close and open. So after they use it, they're gonna close it, and otherwise it's going to always connect to the stove. Right. So other than they use the stove, there is no way the gas actually can go out. And even though it goes out, it's a non-toxic, and it's not gonna work.
And where do they live again?
In Cienfuegos.
And what's coming off of the dump?
Food waste and
Food
trash.
waste, so they just have unlimited
What's
sources.
coming out of the dump?
Gas.
So it's already there.
Yeah.
Yeah,
They're
so the
living
gas
in it.
is already there. So
They're
Yeah.
good.
Yeah, you mentioned like more the plants that were established in Europe, so they were expecting 13,000 something.
Yeah.
Have you guys thought about maybe instead of just doing it for home, have you thought about doing like a bigger, more industrial size kind of thing, clean up the garbage in Biogas, or do you think more into something like the home?
Yeah, we love to. I think that's a final word for us. But as you know, we're the student right now, and there's a first step that we can take is to start as a school and in each house. And if you become adult later,
Hopefully,
and if you like this idea, you can
we
help
might
us.
make an done.
hopefully.
You go ahead and talk a little bit about the reason you can't put permanent things on this location is because they're not really supposed to be there in the first place.
Okay,
Can you
so
talk about that?
yeah, I will explain you more about the Cienfuegos. Cienfuegos, people living there are not there legally. It's a legal city formed by the people from the like a campus of the Dominican Republic. So they go there and build the houses without a permission, government permission. So first they just built 1 or 2 houses, or like they just formed a house like a village. But after that, government came and like destroyed it all. But after they built more houses, so it became a really big community that government cannot really touch. But the people in Cienfuegos still, as you said, like they only earn 200 to 300 pesos per week. And it's, in the case if they go to the dump and work from 9 to 6 without stopping, and if they are lucky, because the incomes are totally based on what they find in the trash dump. If they find the zinc, they're lucky, they're gonna get some money. If they cannot find anything, sorry, their children has to be starving out like us. They have to be hungry. So we're kind of trying to help those people using what we have and what they have. Because we cannot just go give them everything that we have, right? But they actually have a source that can help them by itself.
Do you guys go to this neighborhood?
Yeah, we actually visit there, and
We talked with
That
the
was my
people.
first experience, and it was
Is it safe?
is it safe? Depend on person. For me, I consider it as a safe because I go there. My friends have a ministry there. I go there every day. But actually, it's one of the most dangerous areas in Santiago.
like when it rains, it's so terrible that it's muddy. You can barely like walk.
How did you convince your parents that you? I mean, your parents are there. I guess they know.
Yeah.
But how about you guys? How did you convince your parents that you go?
Like to Cienfuegos.
Uh-huh.
Like they supported me. They said if it's for a good cause,
years ago?
They allowed me because I was going in a group. I wasn't just alone. So as long as I was together with other people, they were fine with
It made me wear a hat.
it.
Oh yeah,
I was a blonde at the time, so that way I blended in more.
yeah. So any other question? Yes.
Since St. Carlos is like a really big contaminated place, did you have to wear like something to?
No, because there's, I think in this way, they're all really contaminated, but they're also wear the same place where the same human live. So if we wear the mask, we're showing that we're from like a different areas. So even though we go there, we don't wear any mask or something else. We try to be in the community as the same people living there.
And like no people are dying. Like it's non-toxic. Like the CH4 and the CO2, it's not toxic. But like these people have been living there for a long time, and nobody's died because of the gas.
Plus, they have animals there, obviously.
Yeah. Any other question?
Right.
Thank you very much.
Thank you guys.